Algebra 2 students, hello, welcome back. It's Mr. Thomas right here. We are here to do another lesson for Chapter 7. Today's lesson, logarithmic functions as inverses. Now, if you remember, when we talk about inverses, we're talking about flipping things. So, the inverse of 3/2 would be 2/3. 2/3. So, keep that in mind as we go through this lesson, that it's a flipping. We're moving things around. So, our goal by the end of this lesson will be to write and evaluate a logarithmic expression. Let's get started. So, what is a logarithm? A logarithm is an exponent. So, for instance, 10 to the second power, or 10 with 2 as the exponent. 2 is the exponent. Now, if you're taking notes, which hopefully you are, remember, if you see something in blue, write it down in your notes. If you see something in the blue box, write that down. So the definition of a logarithm looks like this. Log with the base of b of x, or you could say log of x base b equals y. And if that's true, then if we write it in exponential form, we could say b, so our base moves up, our y, which is all by itself over here, becomes the exponent, and then the x and the y switch, right? So from logarithmic form, the b, small little base number, moves up, and then the x and y switch. So what is the logarithmic form of each equation? So we have the exponential form of 100 equals 10 squared. So we look at the definition of logarithms. X equals b y. And remember, the y and x are going to switch, and the b becomes the base. So when we plug in the numbers over here, our 100 is going to stay right there as a big number. The log, we add that word, and then the b, which was the base of 10, that's going to move down to this base, and then the 2 and the x had switched. And so we'd say log of 100 base 10 equals 2. You're just paying attention to the numbers and plugging them in correctly. So let's look at some examples. So if I wanted to write this in logarithmic form, here's what I'm going to do. I know that I'm going to have the word log, and then it's just a matter of me plugging in the numbers correctly. Now, if you need to, highlight numbers, or put like, okay, this is going to be the x, this is the b, this is the y. If you need to do something like that, you can. Personally, I'd probably just look at it like this. The 3, which is that big number that has the exponent, I know that that's going to be my base. And so I'm going to say 3. I don't know why it looks like that, but that's my base. Then my 81 and my 4 are going to switch. And so this 81, I'll use a different color, is going to go right there. I've got my equal sign, 4. Log of 81 base 3 equals 4. Now you can type this into your calculator. I always keep a calculator in my back pocket. You never know when you might need it. So I can type this into my calculator, and let's see what I get. I get 4. That's correct. So you can check your answer by typing in log of 81 base 3, and you should get 4. So let's do another one. So I know I'm going to have my log and my equal sign. All right, this big number right here is going to be my base, and then I'm switching these, okay? So the 2 is now going to be by itself, and then my 36 goes right there. Now if I wanted to check my answer, I can just grab my calculator out again. Always keep the calculator in the back pocket just in case, okay? All right, plug in log of 36 with a base of 6, and you get 2. All right, moving on. So now we're looking at how would you evaluate or solve for x. So you want to keep in mind the definition of logarithm. So right here we have log of 8, 32. Now you can work through this by putting it from logarithmic form to exponent form. That is perfectly fine if you want to do that. And it may be important for you to know how to do it. Basically what they do is they put it in exponential form, and then they're going to break these down or simplify these numbers into exponents that match, so that they can have a 2 and a 2 right here. And when they have the 2 and 2, those drop off, and they're just dealing with the exponents, and they're going to get x equals 5/3. Now another way to do this, grab the calculator, and I'm just going to type in log of 38 or log of 32 with a base of 8, and my answer, it gives me a decimal, but it's 1.67, but that is what 5/3 is. So use your calculator. That would be my tip. Use the calculator. Let's look at some examples. So like I said, you could put this into exponential form and then try to solve, but the best way is type it into the calculator. So I do want to show you. So on the calculator, there's that little yellow button that says control. You're going to hit the control button, and then just to the left of the 1, there's a little log button. I'm getting really close. I don't know if you can see it or not, but in yellow, I'll say yellow, even though I'm writing yellow in black, maybe confusing. And then you're going to hit log, and that's also in yellow. Okay, and then you should be able to plug stuff in. So if I did that, I'm going to hit yellow control, yellow log, and then on my base of 25 and 25, that equals 2. I do the same thing on this one. Base of 4, 32. My answer should be 2.5. That's all you got to do. Pretty simple. All right. So they give us a word problem looking at earthquake magnitude. So this is kind of like a practical application of logarithmic scales. And on this one, it gives us 2 different values for some earthquakes, and then it gives us this formula. And so basically you're just plugging things in. And so they have it's kind of hard to see that. They have one earthquake at a magnitude 8.7 and one that's at 9.3. And so you're just plugging those in to this equation. The 9.3 minus 8.7 becomes 0.6. And then from there, they're just moving it into exponential form. Now you may be wondering, how did they go from a 10, or from a log to a 10? Well, when you, and I think there's 1 or 2 questions on the homework about this, like this. When you have a log plus, I think it may end up being like log of x, or it may look like this. When you have the log and then either an x or some other variable, when you move it to the other side, this becomes a 10, okay? So when you move the log to the other side, this becomes a 10, and that number becomes the exponent. And then you would just plug that into the calculator, and you would get 4. 10 with 0.6 as the exponent will give you 4. So this is number 10 on the homework. So what I would do is I'd pull up number 10 on MathXL and pull up this page and just follow the steps. All right, that is it. There are 10 questions for this. Make sure You keep the calculator in a quickly accessible area. I will see you all in class. Adios and goodbye.